All right, I think it's time. I think it's about time that we get started. Maybe I can introduce myself very quickly. Good afternoon, everyone, or good evening, depending on whichever part of the world you're joining from. I am Vanya. I am the head of technology for Thoughtworks India, and I'm absolutely delighted to be here to share my experience on building microservices and what does really observability really mean in the microservices ecosystem, and to also question, have you gotten your microservices observability right? Okay, and yes, please don't hesitate to ask any questions. Put them in the chat and we'll come back to that. All right, let's get started. Have you seen this kind of a statement, written somewhere? Well, I have come across such statements umpteen number of times, right? And every time I do see it really annoys me because you know what? We really need to stop saying observability and monitorability in the same sentence together as if they mean the same thing, right? I mean, I have come across so many documents where people, where technologists, developers, or even senior techies, right, monitoring or observability and in a brackets sloppily like logging, right? Because with all due respect, monitoring and observability are not the same things. They are different. They are different aspects, right? Observability is not monitoring, and the same is true the other way around. And in order to understand if we have gotten the observability right or not, we do need to understand what it means and how it is different from saying this sentence that we can see on the screen. Let's consider the scenario or a situation. Imagine there is a profile API and we are measuring latency, which is a metric, right, which is aggregated at the 95th percentile, right? We also have a dashboard where the latency metric percentile 95 is plotted. Now I can see from my dashboard or monitor that the latency value is going up, right? And eventually, after a certain period of time, an alarm goes off in my software system when the 95th percentile of latency crosses a certain threshold, right? At this point of time, we need to know what is the reason for this degraded behavior, right? Why is the latency going up for the last 5% of my requests population set? And that's where we would want to look at the traces of the last few user requests, specifically check the logs of those requests, right? Evaluate the metric values for those specific requests and establish some sort of a correlation with other metrics. Where are the requests waiting? Is it at the API gateway, which is at the edge, or the service load balancer, which is fronting that microservice, right? And probably arrive at some sort of a conclusion on the why. So we see that the monitors or my dashboards could tell us that the latency was high, but it could not and it cannot tell us why was the latency high. So when it comes to investigation or some sort of a root cause analysis or debugging the system, we have to leverage the information that the system itself is emitting out in the form of logs, traces, and metrics. Yeah. uh, and this specific statement, right, we can only monitor for things we predict may go wrong, right? Because it's really important for all of us to understand that in a large, complex, distributed system, the number of variables that are participating in contributing to the health of the system are very, very large, right? And if we sort of permute on those variables, we would have millions of states in which the system can be at a given point of time. And therefore, at a moment, at a given time, we can only monitor what we can reasonably predict might go wrong. Let's understand this very carefully, right? That we can only monitor what we can reasonably predict might go wrong. But does that mean that we do not care about the other states of our system? Well, that's where exactly observability has a very big role to play. And with that, let's look at the definition of what observability is. And in my opinion, this statement that you see on your screen is the true essence of observability, right? As I said earlier, whilst my monitors and my dashboards give me a sense of the predictable and known symptoms of the system, observability is the one that lets me peek into the why behind the occurrence of the symptoms, right? Observability helps developers, operators, the DevOps, how we understand it, understand distributed systems, what is slow, what is broken, what needs to be done, to improve the performance. And observability is definitely the ability to observe the system by gathering the information emitted by the system itself, right? As you can see on the screen, that's exactly how it is. I can look at what's happening with my system by looking at not inside the internal state, but looking at the outputs that the system itself is exposing with the help of the telemetry data, right? And with that, we also come to what are the pillars of observability, right? And without any further, you know, confusion about it, effective observability, right? I'm using the word effective because that's very important. Absolutely requires high quality telemetry data, which is backed by consistent, semantically and syntactically standardized instrumentation, right? Telemetry is the observational data that is streaming out of the software applications that we are building, right? And it is of three types: metrics, traces, and logs. Metrics you define, as I mentioned earlier as well, which define or assess the health of your system, right? We set up monitoring for these metrics, right? We can set up alarms. For example, the example that I took earlier, if the latency is going high beyond a certain threshold, which is a metric, you can be alarmed. You can sort of set off a software alarm which alerts the development team that please have a look, something is wrong, right? Then comes the traces. Traces are like the maps of user journeys, right? They span across your system, right? It empowers you, or the traces empowers you to reconstruct the flow across many processes, many entities, and even across the distributed services, right? Because in a microservices ecosystem, they are all distributed systems. They are running on different servers, different processes. So traces help us go across all those distributed systems. And last but not the least, the last pillar of observability is the actual logs, right? Actual logs of the events that occur. Logs can be of informational nature, they could be of error nature, or they could be as low as debug information. I still remember when I used to code a lot, when we used to write log.debug entering this method and log.debug exiting this method, right? So logs can be of variety of granularity levels. Yeah. Now, based on whatever we have discussed so far, let's revisit our situation, right? These pillars of observability, as we discussed, the logs, traces, and metrics, they have a huge interplay, right? If you look at this diagram once again, right, when I started looking at my monitors, I understand that that the known symptom, which is latency for a given API, is going high. The alarm goes off. I get intimated about that. Then I start the investigation why the latency increased. I go ahead and check my system logs. I go ahead and check my traces for the last year request. I go ahead and check the logs for those requests. I go ahead and check the metric values for those last requests in that point of time. And probably based on this feedback, I understand that there was some other challenge, and probably I will add a new alarm, or I will add a new metric, right, for my APIs. And that's where you see that feedback loop coming in, right? So monitor the known systems, investigate, leverage the telemetry data, and then probably enhance your monitoring such that you can identify new signals, you can discard the noise, and you create that feedback loop. I hope you can notice the feedback loop here, from monitoring to investigation to adding new signals, which can again help you monitor better, right? So that's the interplay between monitoring, observability, and the various pillars of observability. Now let's come to the observability failure symptoms, right? With the need for business continuity and 24/7 operations across geographies, the need is to be able to build, operate, and run distributed systems at scale. And that's where I say that observability failure symptoms, absolutely easy to ignore, but extremely hard to notice, right? The very first one, oftentimes in the microservices ecosystem, where there are autonomous teams working on their own bounded context, we see this mindset that my team service is working fine, rightly so. But if you have dependencies on other teams' services, other teams' microservices, then you are as strong as the weakest link, right? If a business process hops across multiple teams, microservices, who looks at the overall state of the system. There are a lot of pertinent issues that arise, or questions that arise for that matter. Can I trace the entire business process across teams? Can I understand where the time leak is happening? Can I know what are the event propagation times in case we are using an event driven architecture from the first team to the last team in the business process? What are my glue IDs, right? What are the semantics of my attributes? And what are the log retention times of various teams? Where is the log aggregation happening? Are the logs backed up at the same cadence for all the teams? And hence, when we fail to answer all these questions at an overarching level, we see this as one prominent and rampant failure symptoms in the microservices ecosystem, right? Which is failing to establish that overarching view, right? And then I would argue that the question to ask at this point of time would be, who owns the overall responsibility of smooth operations? Yeah. The second failure symptom for observability that at least I have noticed is tracing on the periphery. And is that enough, right? Tracing at the periphery of my HTTP requests, periphery of the database IO. But the question to ask is the periphery information enough, right? What about the business logic where the actual decision is being taken? And in order to find out why the same service is working for one customer and not working for another, we will certainly need more than the periphery telemetry information, right? Therefore, I would argue that the question to ask is, are the support periphery traces enough to support your root cause analysis? Yeah. The next failure symptom is failing to use the open standards, right? As I said, last but not the least, over reliance on tooling to do the job for you. I would say that for much of the recent past, right, proprietary monitoring and observability tools from vendors have been the primary source for useful telemetry from across the application stack, right? But unfortunately, the lack of common standards or APIs across these tools has led to vendor lock-in for customers. And it has inhibited innovation by tightly coupling telemetry collection with the telemetry storage and analysis. And with the growing digital landscape, does your tool provide you the flexibility to evolve at the same rate? And that is something, I would really want all of you who have tuned in to think about. And with that, let's talk about what are the observability principles that have been extremely useful in how I have seen in my experience building software systems with these principles at the heart, right? I would say that speed is crucial to developing and delivering digital services, right? And increasingly complex requirements definitely require observability to troubleshoot issues effectively. And that's where these principles come in beautifully, because they sort of help guide the entire strategy around how you think about your software development, right? Explicit code instrumentation over auto code injection, right? You as a developer know your context well, you know your problem statement well. So that's the reason explicit code instrumentation, for instance, on when to begin a span, when to end it, what attributes, tag, and additional metadata that you need to add is best done when we explicitly code for it. The next one is about open standards over custom tooling. For decades, proprietary drop-in agents from monitoring and observability vendors have been the primary source, for useful telemetry from across the application stack. But as I said earlier, unfortunately, the lack of common standards or APIs across these agents has led to vendor lock-in for customers. And that's the reason we always prefer, or we always recommend the clients that we work with, that instead of using any custom tooling, use open standards. Why do you want to reinvent the wheel? And working with open standards definitely gives you the ability to create better interoperability as your digital landscape also expands, right? As more and more new technologies come in, these open standards help you have better observability across your application stack in a much more seamless way. And last but not the least, observability evolves, right? There is no final done state. You cannot say like a checklist or a checkbox that, okay, the observability for my system is taken care of. In the true sense of, evolutionary architecture, observability as a non-functional requirement is something that keeps evolving. We have to keep a very close eye on how our system is evolving, on how we are observing the system, such that it does not get into a done state, but it always remains in an evolving state. And I think the underlying idea is how can we embed observability in the engineering culture itself, right? If the engineering culture of the organization is not tuned and does not understand the value of what observability is and why is it important, then without these, with even with these principles, I think it will be extremely hard, right? So it has to be driven, it has to be in the DNA of the developer organization or the engineering organization at large. So having talked about observability, having talked about the failure symptoms and the observability principles, let's talk about what can be achieved with observability. I think I've spoken about it enough. Observability lets you do effective debuggability. I can do effective root cause analysis across my application stack on why something is not working, right? It definitely is a great way to reduce my mean time to recovery, because I'll be able to zero down on the issues effectively. I'll be able to zero down on the causes effectively and then make those fixes sooner, such that my business continuity is not impacted, right? Auditability with an asterisk, because you might have the capability, as from a system perspective, to audit the entire traffic that's coming to your software system. But the question would be, would you want to monitor and sort of look at or audit all the traffic that's coming to your system? And that's where, right, in a large ecosystem or in a large software system where there is a heavy traffic, high volume of traffic, you might not want to manage or look at the 100% of the traffic. You can filter and sample on what are those important use cases or scenarios in which you would want to audit the entire system, or such that you can trace through the process, right? And that's where auditability with a star, that you can have the capability, but would you want to do that, is a question that depends upon the context of the business and the application that you are developing. And as I said, yes, observability has a very high correlation with four key metrics. Mean time to recovery is a four key metric, is one of the four key metrics. And if I am having effective observability in my software systems, my mean time to recover is going to be low, which helps me, solve my problems faster, and definitely, amp up the team morale, and team feels pretty much good about it, because these metrics are a direct indication of how productive, how effective that software delivery team is. Yeah. And last but not the least, it helps me make data-driven decisions, because I can observe my system, I can take decisions on capacity, I can take decisions on what's working, what's not working, and reduce the costs, right? Make my business more operational, more efficient, operationally, and a lot many things. In the last section of my talk, I would like to talk about the exemplar client story. In this case, if you can see, there are a lot of Golang APIs, different microservices, right? There are web APIs, there are mobile APIs, and there is Elasticsearch that we are using to get all of this metric data or trace data collected into Elasticsearch with the help of eager exporter and an open census collector, where we have the open census exporter available in each and every Golang API. Because we were using Oracle database, and there was a open census exporter that was available at the driver level, which the driver for the Oracle driver for the Golang ecosystem, we decided to use that. But then we realized that open census collector was listening to this data over TCP, and with that it was slowing down the performance of the Oracle database as well. And that is where we sort of moved to this kind of a structure, where we shifted from open census exporter to an eager exporter, and an eager collector and an eager exporter at the end into the Elasticsearch. And that's where, because it was on UDP, which is the preferred way of collecting log information or trace information over the wire, the performance improved. And with that data being in Elasticsearch, we could build dashboards, whether for business or for technical users, on Grafana, for the metrics in Kibana, for searching the logs, right? And for tracing, the tracing UI that Eager provides, right? Where we could see the spans across the APIs, the entire Gantt chart view for how a specific call is going across the various APIs in my ecosystem, right? So I think this is just an example story of a large bank where we did this sort of an infrastructure, and it worked beautifully like a charm, right? It helped in making the right decisions from an operational level, from a from a development operation level and help the business users alike as well, right? And I guess that's about it from my side, and I'll be happy to answer any questions. Are there any questions in the chat? Not yet. Mm, there are no questions yet. Okay, it doesn't look like people have any question. I think then that's about it. Thank you so much. I hope you could find this talk valuable. But if you have any questions and you would want that to be answered, you can reach out to me on my Twitter handle, which is Vanya Seth. You can also reach out to me on LinkedIn. I'm available there and I'll be happy to answer any question. So this is my Twitter handle and I'm happy to answer any question there as well. And I'm also reachable on LinkedIn. You can search for my name and post a question and I'll be more than happy to respond back. All right. Thank you so much then. Have a good day and enjoy the rest of the conference. Bye everyone.